Let's take a look at this question. In the diagram, R, W, T, and K are the vertices of quadrilateral R, W, T, K. K, the vertex K, has unknown coordinates. The question reads, determine the coordinates of M, the midpoint of line RT. So line RT is an imaginary line. You can draw it in if you'd like, but we use our midpoint formula. And our midpoint formula is x2 plus x1 divided by 2, y2 plus y1 divided by 2. What I'll do next is I will label the coordinates x1, x2, y1, y2. It doesn't matter which one is going to be x1 or x2, y1 or y2, as long as it's consistent. Next, I'll substitute. M is 6 minus 5. Remember, it's addition in the numerator, so 6 plus minus 5 divided by 2, then 6 plus 3 divided by 2. We simplify and we get M is half and 9 over 2. Next question reads, calculate the gradient of line WT. So what I will do is I will write down my gradient formula. Gradient is y2 minus y1 divided by x2 minus x1. Next, I'll label the coordinates. So in this case, I've labeled x2, y2, x1, y1. Again, it does not matter which is x2 and x1, y2 and y1, as long as it's consistent. You could switch them. It'll still work. Next, we'll substitute. So 6 minus 0 divided by 6 minus 3. 6 minus 3 is 6 plus 3. We then simplify and we get an answer of 2 over 3. Let's move on to the next question. Question 1.3, prove that RW, so the line RW, is perpendicular to WT. So perpendicular means that those two lines meet at 90 degrees. Now, if two lines are perpendicular, the product of their gradients is minus 1. We know the gradient for WT. We worked it out. But we don't know the gradient for RW. So what we can do, start with our formula. Gradient for RW, y2 minus y1 over x2 minus x1. Label our points. I've labeled x1, y1, x2, y2. Next we substitute. 0 minus 3 divided by minus 3 minus 5. Minus 5 makes it a plus 5. Next we solve. The gradient for RW is minus 3 over 2. Now we'll take the product of gradients. The gradient of RW multiplied by the gradient of WT. The gradient for RW we worked out as minus 3 over 2 multiplied by the gradient of WT, which we worked out in the previous question, which was 2 over 3. And when you take the product, you get minus 1. Since the product is minus 1, it means that they are perpendicular. Okay, let's move on to the next question. And this is the last question. If RWTK is a parallelogram, determine the values of A and B. So let's zoom in. And if it's a parallelogram, we remember the properties of a parallelogram. The opposite sides are going to be equal in length. Right? So what I'm going to do is I'm going to do a method called the sliding method. And what that means is I'm going to look at the distance between RW and KT. You'll see what I mean now. So if I'm looking at just the X distance between R and W, that's 2 units. If I look at the y distance from R and W, that's 3 units. And if RWTK is a parallelogram, it means that those distances must be the same for the points K and T. So we can apply that on the top. So from K to T should also be 3 units vertical. So if T is 6, it means that A is going to be 6 plus 3, which is 9. The B value. Next, let's look at the X, or the horizontal. That's 2 units. So that means the A coordinate is going to be 6 minus 2, since it's going to the left, which is 4. So let's just summarize the coordinate here. The coordinate K is going to be 4 and 9.